All right, welcome back to our second installment here of our matter and its properties and changes. So the first little small unit we're looking at. And today we're going to look at specifically how matter changes and its properties. So matter has both chemical and physical properties. So by the end of the Zoom session that we'll have on Thursday, we should be able to describe the physical and chemical properties of matter, describe the clues that indicate that a chemical change is taking place, and to distinguish between a chemical and physical change. So a property is a characteristic of a substance. So for example, if I notice that a quarter is shiny, that is a property of that quarter. Or if I notice that water boils at 100 degrees centigrade, that would be a property of water. So it's a characteristic of any substance, any type of matter that we are given. And it describes how that substance behaves and interacts. So for example, with the quarter, it's shiny is describing how that quarter is interacting with light, with photons. Or my example with the water boiling being a characteristic, that characteristic describes how it's behaving when heated. And there are two types of properties that a substance, a sample of matter can have. They are called chemical and physical. And if you like to look at kind of like concept maps, this is a little distillation of what we are going to look at for the properties of matter for chemical and physical properties. So it differentiates the two kind of in a clear, readily accessible way. All right. Now, all objects or all samples of matter have both chemical and physical properties. Now, those properties can be intensive or extensive. What do I mean? So, intensive properties don't depend on the amount of substance that we have. So, we could have a little small speck of salt, or we could have a whole giant heap of salt. Intensive properties of salt will be the same for that small speck and for that big mountain of salt. Okay, so an intensive property, for example, like color or taste or melting point or boiling point or density or shininess or hardness, these things don't depend on how much of a sample of matter that we have. They're always the same. They're always the same. Whereas extensive properties can change depending on if we have a lot of matter or if a little matter. For example, mass and volume and length and shape can all change as we change the amount of matter that we have. The reason that extensive and intensive properties are important are that we can use intensive properties to identify unknown substances. So we could identify an unknown liquid by boiling it and seeing at what temperature it boils, because there will be uh, one and only one boiling point for water, right? Or one and only one melting point for ice, or only one density for gold. So these intensive properties become really useful because we can define objects based on their values. Okay, so both chemical and physical properties can be in these categories. Intensive and extensive just has to do with, does it depend on the amount of substance or is it independent of the amount of substance? Right. Physical properties of matter are characteristics of a substance that we can observe or measure without changing that substance. Okay, so things like conductivity or color or how thick, that's what viscosity means, thickness of of a solution, or malleability, how easy it is to manipulate. These are all physical properties. Boiling point and melting point and density are all physical properties, okay? We don't change the identity of our substance by measuring these. Right? We don't have to have our substance go through any type of reaction to determine these properties, right? They remain the same for all pure substances. So for all elements and for all compounds, these physical properties are the same for that given substance. So um, the viscosity and conductivity and malleability and melting point and boiling point, etc., is the same for all water, or all gold, or all hydrogen. So as an example, water boils at 100 degrees and freezes at 0 degrees. That's a physical property. I can determine that without subjecting the water to anything that would change it into a different substance. All right? Even if it is boiling, it's turning into water vapor or freezing into solid ice. Even though it might look different, it is still the same substance. Other examples of physical properties might be size, might be shape, things like that. Right? Things that we can easily see and measure without reacting our substance with something else. A lot of the times we use physical properties to identify materials, like at a crime scene, right? In paint chips, we can use physical properties to choose a material for a specific purpose, like in construction or engineering. Figuring out the tensile strength and the compressive strength of different materials will give us an idea of which one is best suited for a specific job. And we use physical properties to separate mixtures. So remember we talked about how mixtures were um, two or more elements or compounds just mixed together, not chemically combined. So we can do things like filtration and distillation to separate mixtures based on their size or based on their boiling point, based on physical characteristics, physical properties. All right, so these are things that are useful in industry and in daily life that depends on physical properties of matter. Kind of related to physical properties is physical changes. A physical change is when some of the properties of material have changed, but the material has stayed the same. So for example, if I tear a piece of paper, its physical property of size has changed, but it hasn't changed into a different substance, it's still paper. Okay? Or cutting your hair, the length has changed, that's a physical property, but it's still the same substance. Ask yourself, is the substance still the same after the change as it was before the change? And if the answer is yes, then it is a physical change. So drying clothes or melting ice cream, cutting fruit, you know, reshaping metal when it's really hot, like from a forge, those are all examples of physical changes. The substances aren't changing into different things, but some of their properties are changing. All right, their state of matter, how wet they are, their size, their shape. So physical changes change the physical properties of a substance without changing what the substance is. Now, on the other hand, there are also chemical properties of matter, which are the the measurement of the ability of a certain sample of matter to change its composition. So we can only observe this when we react that substance with something else. So, for example, chemical properties might be an object's flammability or its reactivity, or its ability to tarnish, or its ability to explode. Whenever a chemical reaction occurs, we learn more about the chemical properties of a substance. So here are some different examples of chemical properties: toxicity, oxidation state, heat of combustion, flammability, chemical stability, reactivity. All of these things represent properties that can only be determined by having the substance undergo a chemical reaction and change into something else. So, for example, iron's ability to oxidize is a chemical property. It can only be observed when it reacts with oxygen and rusts, forms a different substance, iron oxide. That's what rust is. Chemical changes are then changes that produce one or new substances. So usually when we observe the chemical properties of a substance, it is because it's undergoing a chemical change. So for example, the ripening of fruit or the rusting of metal, all examples of chemical changes happening. The substance is chemically turning into something else. All chemical changes are accompanied by changes in energy, either losing or gaining energy. So in a chemical change, the atoms that make up a substance are rearranging during that chemical reaction, forming and breaking bonds, uh, arranging themselves in a new way that results in a new material that has different properties from the starting material. Other examples of chemical changes, besides ones that might uh, already have been mentioned, is when you put vinegar and baking soda in a vinegar or baking soda volcano, a chemical change happens. We see bubbles and hear sounds, and we see the level of the liquid rise up and overflow. So a chemical change is happening. Those substances are being turned into new substances through that process of change. So here are yet some other chemical changes, like the rusting of iron. Iron reacting with oxygen to make iron oxide, that's what rust is. Right? The iron is now a new substance after that chemical change. It's rust, it's iron oxide. Burning. Any type of cooking or baking is a chemical change because the substances, the dough and the flour, or the, sorry, dough has flour in it, but the flour and the eggs and the salt and the baking soda, they're all changing into new substances because of the heat. Banana rotting, vinegar, and baking soda, like I mentioned, fireworks, all examples of chemical changes happening, all right? A chemical change. So one thing we want to think about is how do we know if a chemical change has occurred? Well, there are some things that we can use as evidence. So, for example, if bubbles are made, if gas is being produced, that's a sign of a chemical change. If a solid is forming when we mix two liquids together, that's called a precipitate. When we mix two liquids and we make a solid substance, that's called a precipitate. When heat is given off or absorbed, so something feels hot, it's getting hotter, or it's getting colder, like a hot pack or a ice pack. When it produces light or sound, that's a good clue. Or if the color is changing in the reaction, that could be a sign that chemical changes have occurred. So, how do we know if it's a physical or a chemical change? It can be very tricky sometimes because in both cases, a substance's attributes or its properties might be changing. A chemical change will always produce a new substance, like burning paper, we're producing ash, which is just basically carbon. In a physical change, we don't produce a new substance. Look at this. Beaker of water, freezing is a physical change. It produces solid ice, still both water. Different properties, different physical properties, still water. Here is water that is undergoing a chemical change to form hydrogen peroxide. This is a chemical change because before and after we have two different substances. So that is kind of the key to answering whether it is a chemical or physical change. Is it changing into a new substance? Right? That's it for today. This is what we're going to go over tomorrow in class. So make sure that you write some questions down so we can go over and have a nice day.